Problem number 4. This one is a very simple problem disguised as something very huge. So we have square roots, 1 over square root of something plus something, and the series of numbers. Like if you start from 1 here, that brings you 2019. So there are 2019 numbers. This looks like an enormous problem, but in fact, it's a very simple one. So the approach is very straightforward. So even for students who are not practiced like contest math, this should be very straightforward. But because the reason is but this is a very common idea in math contests. So when you see this kind of fraction, what's your first step? The first step always should be to get rid of the square roots in the denominator. So rationalize the denominator. And so we have 2019 terms, and each term has like square root of something plus the square root of next number. So our formula, the general term is something square root of n plus square root of n plus 1. So what should one do when they see this kind of problem? Rationalizing the denominators. What you should do is just multiply it by square root of n plus 1 minus square root of n. Square root of n plus 1 minus square root of... Multiplying by conjugate. I'm multiplying by square root of n plus 1 minus square root of n because the square root of n plus 1 is greater. So what happens when I multiply these two? So I'll get the square... so the formula is the following, very simple one. Square root of a minus square root of b when you do the square root of a plus square root of b. So this product gives you a minus b, a minus c. So this should give me n plus 1 minus n, and the square root of n plus 1 minus square root of n multiplied by 1. So that's the expression. So you see the denominator is 1 because these are 0. So n plus 1 minus n. So as you can see, my initial expression, this one, when I get rid of radicals in the denominator, is equal to this one. So my formula is, if I remove all the calculations that I did, so these are the calculations I did, my formula is the following. This expression is equal to this one. I'll use this formula and rewrite my expression as follows. Instead of 1 over 1 plus square root 2, so 1 is 1 square root 2, I'm going to write square root 2 minus 1. Instead of this, I'm going to write square root 3 minus square root 2. Instead of this one, I'm going to write square root 4 minus square root 3. And so on. And the last one, square root 2020 minus square root of 2019. So as you can see, we have repeating terms. For example, this one and this one, they cancel each other. So square root of 3 will cancel square root of 3. Square root of 4 will cancel the next one. So square root of 19, since we have here 2018 and 2019, it will get cancelled this one. If you look closely, there will be only two terms that are not cancelled. This one and then 1, because we don't have plus 1 and we don't have the minus 2020 square root. So the result is we are left with square root of 2020 minus 1. So this whole entire sum as a sequence is equal to square root of 2020 minus 1. And the entire operation is based on the rationalizing the denominator using this conjugate property of square roots